MAP4C 1.3 sine, cosine, and tangent of obtuse angles. So what we're going to do is investigate primary trigonometric ratios of these 4 points, A, B, C, and D. Recall that we can think of the terminal arm as the angle being measured. It's the straight line. In this case, this is the terminal arm. But we start off at 0 on the x-axis and rotate counterclockwise. We call this quadrant 1, quadrant 2, quadrant 3, and quadrant 4. The points that I've selected are interpreted to be any point within each of the respective quadrants. So notice the following. To get to this point, we have traveled positive x and positive y to get to this position. To get to B, we have a negative x and a positive y. To get to our third point, we travel in the negative direction for x, in the negative direction for y, as well as for D, we positive direction for x and a negative direction for y. This will have different consequences. When we investigate our primary trigonometric ratios for each of these different triangles, we will have different values for positive and negative results when we evaluate these ratios. So sine would be opposite over hypotenuse. This is a positive divided by a positive. The result is positive. Cos, adjacent divided by hypotenuse, is also positive. And lastly, tan, opposite over adjacent, y over x, is positive. And this is true for all of the primary trigonometric ratios in the first quadrant. In the second quadrant, this negative component for x will have certain ratios being positive or negative. Let's investigate. So, sine will be opposite over hypotenuse. Both of these are positive values. R, the length of the terminal arm from the origin to the point, will always be positive because it's a length. And cos, which would be adjacent over hypotenuse, now would be a negative result because the negative divided by a positive results in a negative result. So, lastly, tan is opposite over adjacent. So this also produces a negative result. So only sine is positive in this quadrant. Next, we're using the related acute angle in each case. In our previous example, it's the the angle measure between the terminal arm and the x-axis. So we'll interpret from this point of reference in the third quadrant. Starting off with sine C, opposite over hypotenuse, the result would be negative. Cos, adjacent, is a negative x divided by the hypotenuse, r, which is also negative, tan, which is opposite, divided by adjacent. Two negatives, when divided, produce a positive. So only tan is positive in this quadrant 3. Lastly, the related acute angle is between the terminal arm to get to the point D and the x-axis. So this is our point of reference, and sine is opposite over hypotenuse, negative y over r. Cos is adjacent over hypotenuse. Positive divided by a positive produces a positive. And lastly, tan is opposite over adjacent. So negative y over positive x, the result is negative. So only cos is positive in quadrant 4. A summary of our findings is the following. The CAST rule can be used to determine whether a trigonometric ratio will be positive or negative for an angle based on the quadrant. So CAST is the way that we write it on the Cartesian plane. A standing for all ratios are positive in quadrant 1. Sine is positive in quadrant 2. Only tangent is positive in quadrant 3. And only cosine is positive in quadrant 4. So let's apply our findings. Use the CAST rule to predict whether each calculation will be positive or negative. Check your answer using a calculator. So, sine of 120. This angle belongs to quadrant 2. It's between 90 and 180 degrees. So this should have a positive result. Cosine. Cosine of 145. This angle is also between 90 and 180. Therefore, only sine is positive in this quadrant. Cos will be negative. Tan of 300. Remember, this is 90, 180, 270. So between 360 and 270, 300 belongs in that interval. So in this quadrant, only cosine is positive, tan must be negative. What we need to become familiar with is the related acute angle. The related acute angle is always between, if this is quadrant 1, between the terminal arm and the x-axis, and if the initial angle A is in quadrant 2, the distance between the x-axis and the terminal arm. Similarly, in quadrant 3, this reflex angle, it is the distance between the terminal arm and the x-axis. Lastly, almost a full rotation, but a reflex angle, in quadrant 4, the related acute angle is the distance between the terminal arm and the x-axis. So let's investigate what our related acute angle would be for each of these. In the first quadrant, it is simply the angle A because it is acute if it's in quadrant 1. But when we get into quadrant 2, this is our angle. And say we're given this angle, what is the related acute angle? Take 180, a full straight line, and subtract angle A, and you get the remaining component, the related acute angle. Similarly, if we're given angle A, and we're looking for the distance between the terminal arm and the x-axis, simply take angle A and subtract the straight line, the remaining component, that straight line is 180 degrees, and the difference is the remaining component, the related acute angle. Lastly, if we have a terminal arm in quadrant 4, we can take the full 360 degrees, and if we're given A, subtract the value of A, the remaining component is the related acute angle. So let's apply this. Example. Determine all solutions to the equation sine theta is equal to 0.7760. So step 1 is find the initial solution, and this is what you would intuitively do if you're familiar with solving for missing angles. Our opposite operation for a missing angle is sine inverse, and that we will call the initial solution. We use subscripts in mathematics to give names. We'll call this solution 1. And what we're learning is that there's multiple solutions to this equation. The second solution, let's think, sine theta is positive. So this initial solution is in the first quadrant, but where else is sine positive? Use cast rule to find the location of a second solution. Sine will also have a positive result. I'm not interested in the value, just the sign. Positive here. So the related acute angle in this quadrant would be 180 degrees total minus that initial angle, initial solution. So we now have identified where it will be positive, and to calculate that second solution, we can do 180 minus the initial angle 50. The result is 130 degrees. And if you substitute into your calculator, sine of 50 will give you this answer, and also sine of 130 degrees will solve this equation. Good luck.